Okay, today we are talking about the test for Chapter 4 on graphing. That's tomorrow, and even and odd functions is on there. I hope you'd be able to tell the difference between an even function and an odd function. Does this one have even or odd tendencies? Even. I know I didn't draw it perfectly, but if it were, it would have y-axis symmetry, and that would be even. Okay, so would you please sketch for me something that would have odd symmetry? Draw me a little picture. I'll turn and tell you if you did it right. I'll pause for a second while you do that. Okay, so we talked about even and odd symmetry. This didn't have even or odd symmetry. Some examples of odd symmetry would be like this. That's an example of odd symmetry. It has origin symmetry, and therefore an odd function has origin symmetry. So like if I pick a point here, I go through the origin on the other side, there'd be another point comparable down there. Matches up with it. Okay, next topic is, can you try to prove for me that this has even symmetry and prove that it does not have odd? I keep saying it has odd or even symmetry, and I'm really saying that wrong. I got to clarify that. This function is either odd or it's even or it's neither. And I want you to prove that it's an even function and that it's not an odd function. I'll pause while you try that. Okay, so you should have said that this was f of x. And that this f of negative x, you take the exact same function except you drop in what? Negative x. And then this simplifies down to being exactly the same as that one, which proves that they are even. Now, you do not have to, unless you're told to, you do not have to go on and prove it's odd, because can it be even and odd? No. Therefore, I did tell you, however, that you needed to prove it wasn't odd. So then you needed to do this one, which is negative of f of x. And that should have come out to negative 2x squared minus 8. Main thing is, do you remember to distribute? I put it in parentheses, which makes it really obvious to distribute it. If you don't have the parentheses there, you're likely to forget to distribute it. Anyway, that is not equal to either one of these two, and therefore it means nothing. It's not proof, or I should say it this way. It's not the same as that, and therefore it is not odd. That's what that proves. This being equal to that wouldn't have proved in anything anyways. That doesn't prove oddness or evenness. Yes, sir. Good question. So I get what you're saying. If the kid writes some stuff here and then says it's even, that won't work. You've got to have exactly what I showed here in this little squiggly area. You have to show that you put in negative x. You have to simplify it right. And then you've proven it. So the work has to be right. Because a lot of times we're going to say, it's even, prove it. So we know the answer at the end is, it's even. It's the work in between that matters. Yes? Oh, I gotcha. So if, for instance, you left it this way, you did not prove anything because you didn't simplify it down. You would have had to go like that. Otherwise, you wouldn't have got the credit. So right now, it shouldn't hurt to be wrong because it doesn't matter. What would hurt is if you didn't know that for the test. So, all right, so that's proving oddness and evenness. Now let's go back to our list of things that we had to know. Increasing and decreasing local maxes and local mins and absolute maxes and absolute mins. I think it's best if I just draw you a little picture and ask you some questions about it. We're going to go really quick on this one because I think you get it. But I will find out. Does this graph have an absolute maximum? Yes, it does. Does it have an absolute minimum? No, it does not, because it goes down forever. And you would not say it has a minimum of negative infinity. You would say it does not have a minimum. All right, does it have a local maximum? Does it have more than one local maximum? Yes. Does it have, wait a minute, this spot, it can't be a local maximum because it's an absolute maximum. True or false? False. It can be both at the same time. You can be both locally the strongest kid and the strongest kid in the world. You can be both at the same time. All right, this spot, local minimum right there. Let's say it's at 2, 5. Well, it goes up to a local maximum here at 8, 12. how would we say it is increasing in that interval? How would we write that? You would not say from 2 comma 5 to 8 comma 12 it is increasing. You have to write a way of showing that properly. Try to write it, and then I'll tell you if you're right or not. I'll pause while I answer some of those. So, not everybody answered, which makes me think not everybody's sure, but the people that did answer were getting it right. It's the x values of it, so you'd say from 2 to 8. It looks kind of like a point. You got to be careful on that. It's not the point 2 comma 8. It is an interval from 2 to 8. All right, a little trickier. Tell me how to say that it's decreasing in the blue zone. How would you write that? There's a common mistake. I'm going to see if I can catch a few of you doing that. I'll pause while I check these verbally. Everybody's getting this right. It was from 8 to infinity. And why? What do you think is a common wrong answer? I have to mark wrong. 8 to negative infinity, because they think it's going down. But these are x values. And the x value is not heading towards negative infinity. It's heading towards positive infinity. Okay, good. So let's, I don't know, do you need more time on the increasing and decreasing and that kind of stuff? All right, I feel like you've got that. Let's save our time for the really complicated stuff at the end. Next is moving points and graphs and equations. If I gave you this list of things I wanted the graph to do, I want it to have a horizontal shrink. Oh, by the way, it's a parabola that has a horizontal shrink of 1/2, and it's moved right 3, and it's got a vertical stretch of 8, and it's down 7. See if you can write me a function that would do all of that. Take a parabola from its parent location and do all of these things to it. I'll pause while you write that for me. Okay, in the interest of time, I'm going to start this one. Y equals something squared, shrink of 1/2, right? 3, I am making a mistake, I know, just hold on. And then down 7, stretch of 8. It's got a bunch of mistakes in it, but you can see why you'd make those mistakes, right? Some people probably have this answer and they think it's right. What's wrong with that part right there? Should be a 2. Things on the inside are the opposite of what you'd expect. If you want it to shrink and use 1/2, then you actually have to use a 2 right here. Okay? What else is wrong with it? A lot of people think now that this is right. But it's not. Yes, sir. You do have to have a parentheses on that. And it's not just because they always have a parentheses. No, it's not true. But this is a fine point of order. A lot of teachers even don't get this. Really, like we make mistakes on this part. Do you get when there's parentheses, normally you're forced to do those first. And therefore, since we're on the inside and everything goes opposite of that, that will force this to be first, which is what we want. We wanted this to be first. If you don't have parentheses, and I know a lot of you didn't. A lot of you had 2x minus 3 without the parentheses. What's wrong with yours then? Yours, normally this is first, but yours should have that first. And yours would do the right 3 first, which is not what we said. We wanted that to be second. So you need these parentheses to be right to keep it in the proper order. Any questions on that? Yes. Yes. Well, just to clarify, it's not the same exact thing as a stretch of 2. This 2 we have here makes you think of a stretch of 2, but when it's on the inside, what it actually does is takes your parabola, which was, let's say that was normal, and this 2 here would not stretch it horizontally. It would shrink it horizontally and make it twice as narrow or half as wide. Okay, so what you actually said was, is a shrink of 1/2 the same as a stretch of 2? And it's not. There's a way to stretch this and make it double wide, but it would be by putting a 1/2 in here. To make it twice as wide, you'd have to use a 1/2. All right. Because what you said in words is shrink of a half means here's normal. Shrink of a half is the blue one. A stretch double wide would be like this red one. And they're very different. But the number 2 makes you think of a stretch that's twice as wide, but it's actually only half as wide, and it's a shrink. Yes? It would have been wrong, period. Because yours wouldn't have been in the right order. So again, if you had 2x minus 3 in here, and I know a lot of people did, if I actually did yours, my first step would be go in the inside. And then the next thing is like, okay, what of those 2 things that are on the inside should I do? Multiply comes before subtract, so I don't do multiply. It goes in opposite order. I would be forced to do that first, which is not what I wanted. Okay. Let's go back to the list of topics here. If I gave you a point and I said, I want this guy to move to this spot. Let's say 5 comma negative 2 is on f of x. You don't even know what the function is, but it's on the original function. The new function, g of x, is based on f of x, but it's negative 3 times it. There's a 2x minus 5 on the inside plus 4. Would you please tell me, with all those weird changes, what point must be on the g of x function, on the new function? What point must be on this function? I'll pause while you give that one a shot. All right, so here's the common mistake. People go, so you're saying x is 5. So I'm going to put a 5 right there. And this is going to be 2 times 5 is 10 minus 5. That's not how you do it. So, what should you do? I had that answer. You know what? So many people... Okay, I'm not even sure anymore if everybody just did that wrong or not, because I can't remember what I said was right or wrong. Maybe this is one of those weird ones where it come out the same either way. You want to set 5 equal to 2x minus 5, and then solve it. Oh, it's weird. It comes out to 5 also. That was the worst problem ever by random chance. You could have got 5. You could have got 5 either way. Add 5, you get 10 equals 2x, x equals 5. Okay, that's terrible. I should have had you put in, like, all it would have taken is to put in 6 or something. So I'm going to change it so I can tell who knows what they're doing and who doesn't. Would you please change this to a 6? Everything else is the same. That'll give you a new x value. And I want to see who knows how to do it the right way. 6 comma negative 2 is your new starting point. What would the ending point be? I'll pause while you try that. All right. So pretty much everybody's doing this right. If this 6 were to set equal to 2x minus 5, then I add 5 to both sides. Some people subtracted 5. You add 5 to both sides. 11 equals 2x. Divide by 2 is 11 halves. 11 over 2, or 5.5, comma, what was the other number? 10? And that just comes from, the other number is actually the harder one. You stick in this negative 2 somewhere. But the negative 2 is not just going to drop in to here, for instance. It's going to drop in this whole thing. Because this is f of x. What I'm erasing right now, or scribbling over, is f of x. That whole thing becomes negative 2. So negative 3 times negative 2 makes positive 6 plus 4 is 10. That's how we get the 10 there. All right. Moving on. What if you were asked to take this function and graph it? You could take the parent function, which you know is a parabola, and then actually move it and flip it, and actually there's no flip. Move and stretch, and then move it again, and all that stuff. Or, what did I tell you is your best friend in graphing? XY chart. Would you just tell me 3 points that are on this graph? Yes, you could start with the parent points that are on a parabola and do that whole thing. I don't think you need to. I think you can just go right to an XY chart. So much quicker. I think people underestimate how handy this is. Like, you can graph anything using an XY chart. As long as you know what, like, the equation means. Like, if I give you sine, you don't know what sine is yet. So probably couldn't stick numbers into this because you don't know what the heck sine is, really, for a graph. But as long as it's numbers that you know how to use, it's really no big deal. Please don't put in really big numbers. I'm going to use smallish numbers. So, anybody stick in 0? Raise your hand if you put in a 0. Okay, good. You should have gotten 4 squared is 16. 16 times 3 is 30. 6 times 3 is 18. 48. 48 plus 1 is 49. 0, comma 49. Raise your hand if you had that one right. Okay, good. Then I'm going to stick in 1. If I stick in 1, 1 plus 4 is 5. 5 squared is 25. 3 times 25 is 75. Plus 1 more makes 76. Raise your hand if you had that one. Okay, good. I think they get the idea. Good enough. Negative 1 would have been a lot like, well, it would have been 9, 20. Negative 1 would be 28. Okay. So, that covers moving graphs around, including stretches and shrinks and X and Y flips and all that stuff. So that leaves us with the hard stuff here, which is absolute value of a graph, and I think that's actually easy. And then there's only one thing left after that, and that's the reciprocal graphs. Okay, so here is a picture. I want you to tell me the 2 things, and I think a lot of people are going to get them backwards, so I'm just going to do one at a time. What is it when you do this to a function? Absolute valuing around the outside. Now think it through about, did I just absolute value the x's or the y's? And then show me what you think the answer is. The original needs to not be there anymore when you're done. Your answer does not include the original graph. If you turn it my way, I'll tell you if you did it right or not. Yep. Yep. Nice job. Yep. Couldn't see yours yet. Can you zoom in on a little bit more? It's kind of small from up here. Yep. Yep. Nope. Yep. 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 Can't tell where the axes are, but assuming you have the axes in the right space, yep. 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 Okay. Pretty much everybody's doing it right. So let me show you. Wherever the y's were negative, they now have to be positive because you absolute valued them. So these negative y's here and here and here have to all change to be positive. So my final answer is the blue. This would all stay the same. Now it goes up instead of down. And this would all stay the same. It's the blue one I just drew. And I really should erase these, but I can't carefully erase those. Don't have a small enough eraser. Okay. That's absolute valuing around the outside. Would you please now try it where I absolute value the inside? Looks like this. Tell me what you think it is. Yep, yep. 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 I only have 5 people check, but they've all been right. It really doesn't tell me that much. I know there's always 5 people who get something right. That's right. That's right. Yep, yep. Unless, remember, only have the answer on your graph. Nope. Doesn't reflect back over. That's a really common misconception. I can't tell. Is it just the orange stuff? Yes, then that was right. Yes. Okay. Here's the idea on this one. X's that were negative have to go. This is where all the X's that were negative were. They have to be gone. And then what's weird is that they don't reflect over here and do that. Why? Then you wouldn't have a function anymore, for one thing, because it would not pass the vertical line test. And when you're absolute valuing and you stick in like a -2, the function thinks you stuck in a +2, and it'll give you the same output it did over here. So effectively, that means this whole side gets reflected this way, and so it is a V shape like that. Okay, now let's get to the hardest of them all. These are not impossible by any means, but they are usually hard for kids. So I'm going to give you a nice simple one where it starts at 1 and ends at -1. Just has a little curve on the way. If you had to draw me the inverse of this, not inverse, sorry, the reciprocal of this, that's 1. If this is f of x, then what I want you to draw me is 1 over f of x. Some things you'd start with are f of x's that equal 0, because 1 over 0 is a problem. And the other thing you would start with are f of x's that equal 1 or -1. You totally are lost on this. At minimum, copy down the parent graph and then give yourself room to draw the reciprocal on another graph, so you can have an example for yourself at home tonight. Because these are hard enough, I think I'm going to give you a 3-step process. First, find any asymptotes. And that's where f of x is equal to 0. Why does that cause an asymptote? Because then you got 1 over 0. 1 over 0 can't work. So this is the spot where f of x equals 0. That's where its y value, f of x, is 0. So at that spot, it's an asymptote. How many had an asymptote already on the page there? Good. Next step is there any spot that these graphs will share? Yes. Where the function was 1, it'll be 1 over 1, which equals 1. So it'll be the same. Whoa. I hit the wrong button there. There we go. It'll be the same right here and right here, because -1, 1 over -1 is also -1. Now where do you go from there, though? I'll take a moment. So we know it's got the red asymptotes. We know it touches at this dot here and this dot here. Oops. There. Do you know how to draw the rest of the red graph? Okay, here's what you could do. You could take every single point on this graph just one by one and find its inverse. Like this spot right here. That's a little less than 1. So what's 1 over that? A little bit bigger than 1. Should be like this. What's a really, really small number, like 0.001 or something? Then it's 1 over that, like 1 over 100th, which is like what? 100. So where this one gets really small, this one gets really big. So generally, it looked like that. Raise your hand if you had that one right. Good. And the other one, as this gets really close to 0, it's at negative like 1/100th. This would be -100. So it looks like that. Okay. Let's do one more inverse graph. I keep saying inverse. I do not mean inverse. Just to clarify, inverse we already got tested on. Do you remember inverse is where you flip things over that? So we had a test question look kind of like this. And we said, what's the inverse of that? And you had to know to flip it over the... I'll pause for a moment. So Let's do one more. That's an inverse. What I'm trying to teach you is not an inverse, it is reciprocal. So I'm going to give you one more picture. There. Let's say this is at -1. This is at +1. That's at 2. And this is at -2. Okay, would you please graph the inverse? Notice this is not going forever. This is stopped right there, and it's stopped right there. Make the reciprocal graph. First step, asymptotes. Second step, places where the function would be exactly the same. Last step, try to fill in where the loops go. And remember that asymptotes draw graphs in. It's kind of like a moth to a flame. It's forced to get closer and closer and closer. Pause while you work on that. Okay. You should have said there was an asymptote running right there because it hit 0 there. Was there another place where there's an asymptote? Yeah, because there's another place that hits 0. Asymptote right there. Next, that's a spot and that's a spot where the functions should be equal to each other. And where it hits a height of 2, the inverse of that, not inverse, reciprocal of that, is 1/2, and that's here. So it goes like that. Raise your hand if you had your loop the correct way. Good. Now, how about these things on the outsides? Well, right here, they would share a spot. And where this gets really, really small, the other one gets really, really big, like down here. So up to here, it should have been a no-brainer. But then, what do you do for this? Well, the next spot is I can take that and do the reciprocal of that, 1/2 that, which would be -1/2, like right about there. So there we go. Arrow on this one. And last but not least, this one right here, I was trying to make that at -1, so that means it would share right here. And as this gets really, really small, this one got really, really big. The green one would be your final 1/2, also known as reciprocal, graph. Yes? Right here. That should have touched right there. Yes. That is right. Okay. I know that is definitely the toughest part. Now, your job is to do some practice problems overnight. Some things I suggest. Number 1, look up old ones that we did, that we didn't do, that we skipped. That would be a good place to start. Another thing you can do is watch the videos. I'm going to give you this little practice quiz. I want to warn you right now, the very last question is a beast. So don't be surprised if the very last one looks weird and is kind of a challenge. So this is kind of a combination of little quiz you're going to take in class and something you take home to finish at home. Compare with your friends, see if you get the same answers as they did. That's all I got for you for today.